Alright, so we're finishing up 6.7, and we have our circles that warm up that we were doing yesterday, so we need to find the points on those circles. Again, you're looking for two numbers that add up to 36. That once you square them, they add up to 36. So if you pick two random numbers that add up to 36, like say 12 and 24, you could use the square root of 12 plus the square root of 24 to square those both. You would get 36, and that's the idea. You can be more creative than that, but that's your basic plan. So for this one, I would have square root of 12 comma the square root of 24, or I could put them in simplest radical form as 2 radical 3 comma 24 is 6 times 4, 2 radical 6. And that could be first quadrant points if you wanted. Or you can just kind of leave it. It's up to you. You have a lot of freedom here, so good luck. Make sure they are not on the circle. So in part 2, in part 1, if you recall, we were looking with Veronica's ideas of the 22 degrees around the circle, so basically using arc length on marking one circle and then using that one single circle to mark all the rest. Javier's idea in part 2 is different. He's, instead of doing all of everything, he wants to do the first quadrant first and then use the first quadrant to find everything in every other quadrant. So if you recall kind of thinking about that, we would be able to map, like reflect across the y-axis to find all the points in the second quadrant, and then we could flip the second and first quadrants and reflect across the x-axis to find everybody else. And so that's not a bad idea. I like Javier's. Go ahead and answer that question about what Javier could do to mark the stakes. So Javier's already started working. He's already marked the 10-meter circle. How can we use what he's done to help us figure out how to find the rest of the stakes? So that's your task for this. And if you can't read the angle marks, I remember in my book it was where to read them. So those are the angles and what they're supposed to be. Fewest calculations possible, arc lengths. Now, what I noticed right off is that the center point at pi fourths, or 45 degrees, they're the same number but just inverted. I also noticed here at pi eighths and 3 pi eighths, the two numbers have switched places. The x coordinate and the y coordinate switched to make the next one. And maybe that would be something that I could use to help you. And so the other thing I know is that the points, hopefully we figured out at this point, that the point here on the x-axis is going to be the radius. And it's hard to see it on my picture here, but it is 20. Let me move the picture up. It is 20, and so that would make a big difference being able to see everything. So the radius on this one is 20, so we'd have 20 times the sine of the angle. Make sure you're in radian mode on your calculator. First one's cosine. (20) times the cosine of the angle, comma, 20 times the sine of the angle. And again, make sure you are in radian mode as you go to do this and not in degree mode. Otherwise, you need to switch to 22.5 degrees. So Javier's, he's found his radian measure and he's moving to radians, which is something we need to learn how to do. The S right here is important. S is the arc length. And so we need to find the arc length, but this is going to be the ordered pair for the point. And so we need to find the arc length, which is going to be the radian measure, or I don't remember. Give me just half a minute. Okay, so if you didn't figure it out yesterday, to find the arc length using the radian measure, all you have to do is take the radius and times it by the radian measure to get the arc length. And so we've got radius 20/8, and 20/8 is 2.5, or 5/2, so 5/8. Excuse me, 5/2. I misspoke. And that is approximately 7.854. So S on this point is 0.7854. And then the other two measurements are, this one is 18.478, and 20 times the sine of pi8 is 7.654. And based on what happened with this point and this point, I'm going to say that my ordered pair over here for this point is going to be 7.654, 18.478. This one's easy. 0,10. This is 0,20. We'll get into the arc length in a minute. What is my angle here? This is pi-halves, or 90 degrees, up top. And using the shortcut for S, so 20 times 3/8 is 15/2 pi, which is approximately 23.562. And then this one is 14.142, 14.142, because they're going to be the same. And S at pi fourths is going to be 5 pi, and 5 pi is approximately 15.708. Now, I use 3 decimal places because that's what we've been trying to practice for ourselves. And this goes down with that one. But they use 2. So it might be, for pattern seeking, better to look at only 2 decimal places and what happened pattern-wise. So we look at 9.24 and 18.478, which would be 18.48 if I had left it at 3 decimal places. It looks like it's been doubled. So you can see that. And since the radius has been doubled, so we took 10, then 20, maybe we just times by the change in the radius, which was times by 3, times by 2, excuse me, and got that number. Did it hold fast, like 7.07, 14.14? That it worked for that one. And does it work for this one? Yes, because again, they're just switched. So just timesing by 2, doubling those numbers. So I wonder if timesing by 3 will give me my next arc, and timesing by 4 will give me my last arc. What's happening with S? Can we see a pattern there? Is it doubling? And it is also doubling. So you can use, if you stare at that long enough and see the patterns, you can use that to go further out. And just by finding one, and since of course we used multiples of 10 as our radii, we can times by 2, 3, and 4 to find the rest of them. So good luck with that. The homework today is talking about different ways to write ordered pairs. And so we've got x, y, where we know that x is the x movement and y we already know that. We've also established that x is very related to cosine and y is very related to sine. We'll spend more time with those relationships. R is the radius, theta is our angle, and S is our arc length, and we're going to be coming up with different ways to describe the ordered pairs on the circle. So we've got the rectangular coordinates that wants you to find R and theta and S, and then write the ordered pairs. That's what the number 6 asks you to do. Number 7, it's probably number 1. Number 2, find R, theta, find B and R. So notice it's left out the S. Find S, the arc length, even though there's no C over here. So in order to do E, you probably need to do C. Excuse me. So, and then it's the same idea. They're giving you different ordered pairs and asking you to go backwards and vice versa. So just kind of think it through. This is fairly straightforward. It's a little weird because you have to kind of know different things, but it's just a matter of translating the coordinates with what we already know about how to find R, which is x squared plus y squared, take the square root. How to find theta, which you would need to set up either sine or cosine and then do the inverse after you find R. And then how to find the arc length, which if you have the radian measure, or you can use the proportions that you've done. So good luck, and I will see you soon.